Hey guys, Jake here, coming at you with another math lesson. Today we're going to be continuing our discussion about logarithms. Specifically, we're going to be going over properties of logarithms. So there's three main properties that you want to keep in mind when you're working with logarithms, or natural log, it's all pretty much in the same category. They have the same properties and all that. So this is going to apply to both, no matter what the base of your log is, whether it's a natural log or log base A, log base 10, log base whatever. So these three main properties, they're going to really come in handy when you get into a handful of different types of problems. And we're going to kind of touch on some more types of problems in the coming videos on my channel. But we will get into a specific example of a problem where these properties really do come up and are pretty helpful. So, like I said, there's three main properties of logs that you want to keep in mind, or properties of logarithms. There is the product property, the quotient property, and the power property. So let's get into what these actually tell us. Basically, they just tell you how you can algebraically kind of reformat logarithms if you are given a log in a certain form, how you can split it out into multiple different logarithms. So let me show you, for example. The product property tells us if we have log base A, base anything, like I said, doesn't matter what the base is. If it's natural log, so log base E, or log base any other number. If there's no base written, that just implies log base 10. This still works. So if you have the log of two things being multiplied, so in this case we have the log of u times v, we can split that out into the log of u plus the log of v. So notice here, as long as you're keeping the base the same for all these different logs that you're splitting it out into, it's going to remain equivalent. It's going to be equal. So basically, you can rewrite the product, log of something times something, as log of the first thing plus log of the second thing, okay? And again, as long as you keep the base the same, so if you have a natural log, that just implies log base E. As long as you keep it as natural logs, it works exactly the same. Natural log of u times v is just the natural log of u plus the natural log of v. So the reason why this is nice is, look at what you've done here. You've just split this log of two things that are, being multiplied together, which kind of just makes the inside of your log, the stuff stuck in the logarithm, a little bit more complex. So like I said, if you had some variable within this that you're trying to solve for, this allows you to split it out into multiple smaller logs that have kind of simpler things that you're calculating, which can make it easier to then solve for one of the variables within your logarithm. So like I said, I'll go through some examples on my channel in the coming days, coming week, just going over some different problems that use that. So if that's something you want to see, be sure to go hit that subscribe button and that bell icon down there, and we can go through that. But like I said, I will go through an application of these different properties in a second. So the second one is the quotient property. Very similar to the product property. It just tells us how we can split log base something of u divided by v. So if you have division within your logarithm like this, u over v, you can split it out into the subtraction between these two logs. So log of u minus log of v. So again, as long as your base is staying the same, you can just split log of u divided by v, or log of something divided by something, as log of the numerator minus log of the denominator. So the top of your fraction minus the bottom of your fraction. And again, same thing for natural log. Natural log of u over v as natural log of u minus natural log of v. Okay, so the only difference between the product and the quotient property is if you're taking a product, you add them. If you're taking a quotient or a fraction, you subtract them. So that's it. It's really a very similar formula. You just have a minus sign versus a plus sign. Okay, and then the third one is the power property. This one looks a little bit different, but really kind of a similar idea. And again, notice as long as you're keeping the base of your logs the same, so natural log will stay as natural log base A, log base A. If you had log base 10, it would just stay as log base 10. But if you have log of something to a power, log of u to the n power, for example, you essentially can just move the power down in front of the log and multiply it. So we just get n times log of u. So that's all you're really doing. You're basically just moving the power down in front and multiplying that by the log, and still taking the log of the same thing. So it's still natural log of u, log base A of u. So pretty straightforward. Now let's get into an application of this. Let's say we had a problem like this. We want to use the properties of logarithms to rewrite and simplify the logarithmic expression. we have log base 2 of 4 squared plus 3 to the 4th. Before we jump into that, I do want to say real quick, if you haven't already, go check out my Precalculus study guide. I just recently came out with this. Just go to jakesmathlessons.com/precalculus-study-guide, or use that QR code in the upper right-hand corner of your screen. It's going to be a huge time saver for you. It's going to help you as you prepare for tests, as you do your homework, anything that you're doing in a college algebra or pre-calculus class. So go check out that link. There's tons more info there. It's available for instant download, so you can literally have it in seconds if you just go there. So back to this example here. We're going to use these properties of logs to rewrite and simplify the expression. So in other words, kind of what we're trying to do is take this really complex log and expand it out into kind of smaller, easier to deal with pieces of different logarithms. So when you're doing this, you want to think about basically the order of operations that you would apply when trying to evaluate this logarithm, and we're going to kind of break it apart in reverse order. So think of PEMDAS, right? PEMDAS is order of operations. PEMDAS says we're going to do whatever's inside the parentheses first. Well, in this case, we just have these parentheses. I mean, really that just tells us we're applying the log first if we were to actually evaluate this expression. So we would need to figure out what to do inside this. Okay? That's kind of a given based on the fact that we're trying to use these properties of logarithms to split this apart into smaller logarithms. Then we're going to deal with exponents. So then if we were to evaluate this, we would kind of figure out what this 4 squared piece is, figure out what this 3 to the 4th piece is. That would be kind of our next step. Then from there, we would get into multiplication and division. So then we would do this multiplication step. So what that tells us is if we're trying to split this logarithm out into kind of smaller, easier to deal with pieces, we need to go in the reverse order. We need to apply the product property first, because the multiplication would be kind of the last order of operation we would do. So we need to kind of go in reverse order, break apart the multiplication first into 2 smaller logs. So what does the product property tell us? How to break apart the log of something times something else. Well, if we just go back up here real quick, if we have the log of something times something else, we just break it down into the log of the first thing plus the log of the second thing. And remember, just keep your base the same. So we're going to break this down into the log of 4 squared plus the log of 3 to the 4th. And again, just keep base 2. So this will be equivalent to log base 2 of 4 squared plus log base 2 of 3 to the 4th. Okay? That's equivalent. So now, looking at each of these logs, we want to think about how we can break that down into even smaller, simpler pieces. In both these cases, we have log of something raised to a power. Log of something raised to a power. So we're probably going to want to look at the power property, which again just says if you have the log of something raised to a power, you just take the power and bring it down in front of the log and multiply it as a coefficient. So that's all we're going to be able to do here is just move our power, our 2, down in front of the log. So we'll get 2 times log base 2 of 4. So we've just taken our 2 from our power and moved it down in front as a coefficient, and then left basically everything else as it was. Same thing here. We're just going to take our exponent, move it down in front. So 4 times log base 2 of 3. So now this is equivalent to what we had up here. So now what we've done is we've basically broken this all out into the simplest terms we possibly could. Now, if you wanted to, actually evaluate this log, I mean, in this case, they pretty much just told us to rewrite it and simplify. So, really we've kind of done the problem in this case. But if you wanted to actually evaluate this expression, we could then use the change of base formula, which I have made another video on. If you just want to go click on that info card up there if you want to check that out. But the change of base formula, we would be able to then rewrite this as 2 times log of 4 over log of 2. And this would be like a log base 10, which you can actually plug into your calculator. And then we'd have 4 times log of 3 over log of 2. So again, that's a topic for another video, but now we would have an expression which you could just plug into your calculator and get an actual number for. So that's how you apply these properties of logarithms. If you got some value out of this video, do me a huge favor. Go hit that like button down below. And if you do want to keep this brain train rolling, maybe learn about some change of base formula, just go click that video right up there, over there, sorry. And let's keep it going. Thanks, and see you next time.